that, so any kind of results from stars, Costanza gave a very nice review yesterday. That sort of thing, if we can build up a large number of such slides, that'll answer the question of the legacy automatically.
Jesus had his hand up a moment ago, but Amruta, I think you had your hand up and you took it down. Did you have? I missed it before.
No, that was about recording the conversation, but I posted it in the chat. So yeah, sorry.
Recording. This is
So the first question here in this document is: if you had 5 megaseconds of Chandra time, what would you do? So I personally, because I have worked in Wolf-Rayet stars, I will go for observing a default, because LEDA said that we only have this nitrogen type Wolf-Rayet star, like extremely
one single star.
One single star, but we have carbon stars, oxygen type stars. Can we observe them, or they will never be detected? I see LEDA shaking her head.
Too soft or too very...
It's really hurting their decline of efficiency below 1 kV. So we can go. I mean, the instrument is now 25-year-old, so we can, when everybody combines and say we must observe, for 5 megaseconds one star, it will make great advantage of science. We can do it, but I think it is simply not feasible with current decline of soft area. We will not get any CNO lines. So my personal, sorry, CNO. LETG. I don't know. The expert. I should ask the experts. David, Vinay, can one do LETG?
I don't know. We need a model spectrum, but with LETG or HETG with HR, you'd have to use HRC. We'd have to use HRC to get the soft response.
Yeah.
Well, I'll mention WR1 might be a possibility, but I'm not sure for Chandra. And then there was a nice study of B444 sig, but that's a close binary. And then, but there's also Theta 1 Ori C. Mark Gagne mentioned how it's not a Wolf-Rayet, but it's a magnetosphere and it's a unique data set. But it would be nice to have a cousin. I don't know if Sigma Ori E, those magnetospheres can have a lot of hard emission and stuff like that. So that would be, an investment. I was also wondering about runaways. Runaways are a popular topic these days. I'm not sure how much has been done with runaways, but they create bow shocks depending on where they're situated with respect to the galactic plane. And I don't know if there's value there that crosses some interest of lines, but Dave, you got your hand up.
Yeah, it's two things. Just thinking about supporting future missions, is there anything we think Chandra should do to support some of the lower spatial resolution instruments? Like we have great data on Orion. If CRISM were to look at Orion, it wouldn't be resolving the sources, but we can tell them where they are. So if there's something else like that, like maybe in the Magellanic Clouds, I don't know.
So that represents a version of legacy that is handing off of the baton. Right?
Preparing for the next missions to do things that they can't do that we need to know. I don't have a list of those, but it's something that we should think about.
Just to write that down, what can Chandra do for future low resolution missions?
Yeah, well, lower spatial resolution, right? Yeah, because Chandra has the best spatial resolution.
That's actually one.
And something like that we've been involved with. Moritz had a project. He wanted to observe Orion with NuStar, but NuStar is not going to resolve the objects, a flaring star. But if you get it with Chandra, you know which one flared, and then you can analyze your data. If you didn't do those both together, you couldn't do it. So it's either preparing for the next missions or supporting them during their observations. So I don't know if anybody's looked at the CRISM program and said, what do we need to do to support it that we could do with Chandra? Second thing is just thinking of things to do, like Wolf-Rayet stars. A lot of them are eclipsing ring binaries. What can we learn if we could study them around their orbit? It's hard to do the timing with Chandra, one little proposal at a time, getting one little bit of phase. And there are two big projects. There's Itacar and WR140. They have had big campaigns to study those. Is there anything else?
Well, I mean, that's very elliptical, but I don't know how close it gets, but its ellipticity is like 0.6 or 0.8.
Yeah, so there are several of these systems like WR25 and some other WR stars. They're, you know, they're not the single WR star that you learn about the wind and isolation for everything else, but maybe from the changing wind dynamics, but you need an orbit or two covered pretty well.
Yeah, I have followed the business, but go ahead.
Well, let's different topic. But
Okay, yeah, go ahead.
But there's also X1, I think, which I don't know how well the orbit is.
Big X1, I think there's a big campaign on that too,
Yeah.
because that's a
That
neutron star. Yeah, the neutron
X1.
star plowing through clumps.
These that would be actually be a fill-up kind of thing. Not only a sample of sources, but also one source where you get the complete orbit. If it's a long orbit, things like that. That's a good point. That's not what I raised my hand for.
Sure.
Yeah. I mean, what I think, I mean, we haven't mentioned the TOO program, because when you have a TOO, you basically have a new source. The problem with, like, for example, cool stars or low stars is that the bright ones have already been done. And, you know, when we want to do deeper, we need deeper, longer, and we're fighting against the reduced soft response. But if we have a new source, you know, then I'm campaigning for our Novi, for example. It's an example, but because that goes to my heart. If we have a new nova and we want to observe a new super soft source, these are very, very bright, and even with a low soft response, we have so many photons. I mean, just need to correct for pileup in the grading in the RGS, so they're so bright it doesn't matter what the soft response is, and each one of them is different. And they should be observed.
No, but not the quiescent.
Not the quiescent. I mean, when they're in outbursts, that's
those are not that often. No, I mean the quiescent super soft source is permanent burners. What we
no, I don't mean
those can be faint, especially because we see them maybe in directions of low column density, so in the Magellanic Cloud.
Yeah, sure. I mean, but we detect them with Swift. You know, Swift monitors, and the moment we have a certain count rate threshold above which we know we're going to get plenty of counts.
Yeah.
In the LETGS.
Yeah, we can do some of them. We can do short.
Right, and then they can be done with relatively short exposure time with the gratings, and they're all new. They're also probing new lines of sights. You know, for interstellar torsion lines that one can see very well. The LETGS are actually unique, like carbon 2 torsion lines and the 42 angstroms and things like that. I think an emphasis on TOO and to boost that a little bit might be a good legacy for Chandra, because, you know, like in our example, you know, because they're so diverse, these sources, if we have many of them, then one can actually get some hopes to get classification criteria.
So you think increasing the shortening the TO response and not
no, increasing the priority in the observing program for TOs. They of course have an impact on scheduling and so on, but if you have long response TOs, I think there is a lot of potential in TOs. I don't know so well the approval process, but TOs are not so easy to get.
Well, this actually brings me to, this dovetails very nicely to what I was going to say in response to Jesus' point, that the question was posed about the 5 megaseconds. And you're referring to this idea of maybe increasing the amount of time available for TOOs.
Yeah.
But in relation to legacy, and maybe some of the insiders can address this, to what extent would Chandra rules operations have to be bent or broke in order to accommodate something truly unique, as Chandra's kind of in this declining period? I mean, when you refer to legacy and doing something, does that mean a change in procedure and protocol? What would be accommodated in order to achieve legacy?
This is just a comment on what Ness was talking about. So I think like this is the first time, I mean Dave and Moss will know it better, but probably this is the first time that Chandra panel actually had a TOO, at a panel to only discuss the TO proposals. So maybe you're already thinking about it. So yeah.
I see.
It made the review easier.
Yeah, so it's just a list of, you know,
But we
instead of mixing it.
schedulers certainly don't like TOOs because it gives them a 2-week frenzy to but they have that's why they're budgeted, is to make the scheduling manageable.
Sure, but we're talking about legacy.
And there are fast ones. The fast ones are really limited to 0 to 5 day trigger. And then there's the 5 to 20 day trigger, which are okay, and the greater than 40 are.
But why doesn't Swift have it covered already? So once
it's a completely different mission. It's made for TOs.
Swift has the low Earth orbit, so you have these gaps in between. You can hardly do any good timing studies in the 20-30 minute region. And also the effective area is, of course, much lower.
So the other aspect of the legacy, of course, is how might Chandra be used jointly with other instruments, other platforms? That's a different aspect of legacy. So let's recap the legacy possibilities. One is like the handoff to the next gen. One is like joint things, partnerships. And then the other is like the 5 megasecond. What would you do with 5 megasecond? Are those the basic categories? What kind of legacy seems to fall in?
Just want to respond to Dave, because you said, okay, it is of course expensive, the TO program, but when we talk about legacy, we need to see what kind of price one is willing to pay, because you know, there's a good scientific value.
Right.
I mean, I'm in science operation. I also hate the TO.
Well, yeah. So
Chandra is worse than your XMM operations because it eats up more.
Sure.
And so we are really limited now. I mean, I'm not in scheduling, right? But we are really limited in which parts of the sky you can look at all. And that just makes, when you have a TO, that means you rule out large parts of the sky for the next week.
Yeah.
Essentially. And so it's not just about cost and people, it has a significant impact on what else you can look at if you accept the TO. Because Chandra eats up so much and the server properties are decaying.
And that's another twist on legacy, is to say, given all the various constraints, what exists in that ribbon with that cadence and so on, that would be the best thing to go after that so far is lacking. That's not something I'm very good at knowing, but that's one way to frame it.
On what Chandra can do for future low spatial resolution missions, have you thought about a little bit on the sense that, are you willing to make joint proposals?
It's a possibility. It doesn't have to be. It can be just, we need to map out these fields before or after PRISM observes it.
Does it joint and simultaneous are two things, right? So with joint can be simultaneous in the story, that would be different.
It's time variability.
The variability.
So it's you know, it's an open question as to what support is useful or necessary. Right.
The LETG could be paired well also with NICER, because NICER can collect lots and lots of photons that Swift doesn't, and has the softest response.
Yeah. Well, we already have the checkboxes on proposals to do joint observation.
Right.
And,
but I mean,
and the observatories allocate time for each other. Yeah.
Lita has a hand up.
I mean, just to think about what are the main thoughts.
If I can throw in idea which is not well thought, it's just random, and my time of the work is now 1 a.m. So if you just, you know, can I throw idea? And we are not recording, right? So it could be entirely stupid. I was thinking about maybe we should step out of the box, and we're doing stars here, and we always think about galaxy, and I think Marina and others mentioned other galaxies, but maybe we should completely step out of the box and think, for instance, about lensing, you know, lensed clusters, lensed, you know, what is GWC is doing now, you know, higher redshifts, etc., because only Chandra can do spatial resolution. And okay, as I said, I didn't think about it. You know, what is maybe the soft response will also kill us because, you know, redshift. Maybe some lensed star forming region would be interesting for Chandra, or maybe people already tried it. I mean, it links with stars. I'm not talking about black holes, AGNs. I'm talking about star formation at high redshift. But I didn't think about it in detail. Maybe it's stupid.
Interesting. I mean, lensing is wavelength independent.
Yes.
So when you have an optical lens, kind of this arc, and you have reason to assume that the lens source has sufficient X-rays, that would be quite spectacular.
I mean, if somebody can think about it, so there are now papers coming in archive each day, that redshifts which are modest, about 2 or something. There are really bursts of, and high redshifts too, but maybe, I don't know, maybe that's too high. They're really very high star formation rate galaxies, and they will have all kind of things there. And as I say, XMM and all others, Athena, etc., they are absolutely useless with it. One would see point source and know nothing if there are X-rays. Maybe, some crazy trillion-second Chandra proposal for one of those fancy things could be interesting.
I mean, that would be like known lens arc kind of things, not microlensing. I don't know that Chandra's ever followed up on a microlensing announcement, but I'm not sure the sources are suitable necessarily. But I would guess that Chandra's done some well-known lens sources.
Should think so.
Yeah, let me ask you this. Let's go to the cool side of the HR diagram for a moment. There's this long-standing problem, the Linsky-Heiss dividing line, right? Where the M giants and super giants don't show X-rays, but they have chromospheres. As the K and D giants, they have coronae. Has that problem been addressed?
That was it used to be a big thing back in the 90s, but then we figured out that several of the cases which were classified as hybrid happened to have a low mass companion that was the X-ray source. So the entire the so-called hybrid star category kind of vanished.
Okay.
So yeah. But following up on what Lydia was saying about extragalactic sources, I know that there's a program here where people like Rosanne Di Stefano are trying to monitor LMXBs in nearby galaxies in the hope of catching eclipses from planets around them. And it's right now it's like searching for a needle in a haystack. But if there is a targeted program, that might be useful.
There is a concept about exoplanets that are edge on and moving and eclipsing coronae, right? That's been done with Chandra, right?
Yeah.
Again, it's a soft response problem, and that's kind of but something that Arcus the project was thinking about, is looking at the absorption as a planet during planetary transit. The atmosphere will have some absorption, small fraction, but if you have high signal and noise, you can detect the spectral signature of an exoplanet atmosphere.
Are there powerful flaring stars with exoplanets, and you can get some information from that? Has that been done? That's interesting, potentially, but
what people started doing is detecting planets, or at least Jupiter-like planets around white dwarfs, and they are supposed to produce hard X-ray emission. That can be done.
Yeah.
I think it was studies of metal polluted white dwarfs, right? Quite extensive, using high resolution spectroscopy. It is super interesting, I think.
We haven't addressed this much. I think there was some interest in accretion disk phenomena. Is there an outstanding problem where 5 megaseconds would just nail it?
We have to go to the HRC pledge. There was a large project for TW Hybrid, which is the prototype, the nearest, brightest system. That was done before the contamination was high, and the data are good. The models don't explain it yet. We need another case like that. You had a large program on P4046 SAG with RGS, right? Yeah. That's the next best case. So I guess still it's an open question, but that's one of Warren's favorite topics too, and it's hard to do with gender these days. Just some jets around.
Jets, for jets, I think we are lost.
Yeah.
I've looked at observing the DG tau jet and getting a high HETG spectrum, and after 10 megaseconds, I still won't see anything in my simulation, so I've given up.
So what are the deep spectra we have that we really like? I mean, we've got like Zeta Puff, we've got WR6. I mean, what do we need to fill in?
TW Hydra,
TW Hydra,
EX loop,
EX Hydra.
EX Hydra, sorry.
Is a polar with a deep spectrum.
V44.
V4046. Right, Zeta 1RC, of course. I mean, we have beautiful spectra from these, and it's pretty Capella, and they've been pretty productive. Oh, so we don't need any more. Let's go.
That's why I asked another spectral type for warp-based stars.
Yeah, right. Yeah, so maybe that's.
Well, algo, I think would be, there's not a lot, but they have, for instance, eclipsing binary where you can localize flares when they happen during eclipse, which I think was seen twice. I don't know, but at least Jürgen Schmidt. But I mean, continue staring at algo, and that's a hard spectrum. So that should be doable. It could be, 5 megaseconds, just monitoring algo.
And what's it going to tell us that we don't know, I guess?
Yeah, that's of course. I mean, Jeremy has done some work with. I mean, you can see line shifts actually. So Jeremy determined the, actually the source of the X-ray emission being the K star rather than the B star.
Yeah.
I don't know whether that is sufficiently accurate. Probably is.
Are there more line shift things you'd like to do? I mean,
I think that's one thing around where could be
theoretical.
If I can steer up a little bit, there's two more points that we could discuss. One of them is that is it more fruitful to find new targets or reobserve known targets? That's the one thing. And the other one is, what would you do with 30 kilosecond exposure?
And into the next 30 kilosecond exposure.
Accounting for the loss of effective area and SSS.
Although everything's broken up into pretty much 30 kiloseconds or less. So if you need 200 kiloseconds, you have a lot of exposures, and it's just software to combine them. So you still go for what exposures you need.
But 30 is actually the TO thing, because you get sources which are, if they're bright enough, they are new, right? Because with 30 kilosecond observation, what can you do? Because everything that can be done with 30 kilosecond is already done by now. If these are normal sources, if you're transient sources.
Okay, for us, it's not. Maybe for ATN people, it's still 30 kiloseconds still useful, but not for us. That's what you say.
And the opposite, I would say.
At the opposite.
Yeah, we usually need hundreds.
That's my point. We
ratings
30 kilosecond observations are not enough for us. It's not enough for us.
But it can be something that's already been observed.
It's enough
like
for
the Zeta Puff program.
For X-ray binaries, for novel.
Based on the original 70 kilosecond observation, because we need 800, not 70. So if you have a good justification, you can reobserve something.
Actually, breaking up into 30 kiloseconds has helped for some of the science cases that I studied, like extra binaries, when I had to, it has a lot of variability and you want to sample it at different, states or whatever. So that has really helped 36 kiloseconds. Yeah. So that's the kind of science that you can think about, short exposures.
Then the other one, of the already observed ones, which ones would you like to reobserve?
Lots of them.
I'm going to start somewhere.
So, gamma cas analogs, I know I'm more familiar with the massive bars, but that being gamma cas analogs seem to be interesting and they're hard. Gamma Cas itself is hard. But I don't know how much has been done in terms of its variability. Also, in terms of probing physics, I've been told that all massive stars are binaries and every O star will at some point have mass transfer. Now, I don't know, that might be soft, but with Chandra's spatial resolution, aside from Orion, but somewhere else looking for compact core of a cluster and trying to find hard sources in there. It's early. Of course, it might have high column. I don't know. Is there interesting physics to be probed? Like Gamma Cas is basically it's unclear what's going on there, or say BE X-ray binaries where compact object is plunging through a disk and you know the period. Is there something to be gained there? I'm not sure what else there is on the cool star or young stellar object side of that. But
I wanted to ask a question. Can I?
yes, please.
Yeah, so with respect to what the question that was raised, that can we re-observe some things? What I was wondering is that out of the catalogs that are available to us, and in your opinion, would there be something that we have missed in the present catalog, or have they been completely exhausted and searched for whatever possible physics?
Great question.
Because a part of my work is building multi-wavelength, spectra of different sources using catalogs that already exist. So, in your opinion, is there some sources or some catalogs that have not yet been exploited to its full potential that I can look into? In your opinion,
Lita, do you have a response to that?
Yeah, I absolutely think that catalogs by far not exploited. You can start with Einstein catalog, or even Uhuru catalogs. One never knows because it gives you timeline. It's 60 years of observations to start with. And the latest catalog, Chandra and XMM, I think we didn't barely started. My feeling. I like catalogs. I think there's a lot of information. People like to apply for time because, it's motivating, but catalogs already contain it all, actually.
Well, there's also more.
So good, interesting project you have.
More than one thing to do with a spectrum too, so you never know what else will be done with a high dispersion spectrum.
I mean, years
and
ago.
are there some sources? Sorry.
No, go ahead.
No, I just wanted to ask, Lydia, do you have some sources in mind that you were saying that a lot of catalogs have not been exploited, like Einstein? You have some sources in mind that you think they're present in these catalogs, but we haven't explored them?
I mean, of course, it's a complicated question. I don't know from top of my mind, but the first thing to come, for instance, to take big bunch of coronal stars and look for their periods, or I don't know. To be honest, I don't know. Is it feasible or not? Because of course, different missions, different spatial resolution, different responses, how cross-calibrated they are. So that's I don't know. But particular type of sources, I don't know. I was recently working on X-ray observations of some white dwarfs, and I went to really catalogs from 50 or 60 years ago just to check. You never know what one find. One needs careful work, but I don't know, maybe other people know better than me or have some other ideas.
I was gonna say sometimes these things are serendipitous. I got time for Beta Lyris Suzaku way back in the day, and it was because there was a suggestion that ROSAT saw something hard. We didn't end up seeing much that was interesting from it, but it was useful to follow up. So maybe there's objects looking like that, floating around. But there's so many constraints with Chandra. It seems to me to look for the sweet spot in terms of the cooling issue, in terms of penalties across the sky, and all those kinds of things. Just, you know, kind of mark out that ribbon, and then see what the objects are where it's more than just incremental progress, but something substantive, and it would match well, like say the cadences that are available, maybe a rotation period or an orbital period or something. So a bright source, good spot in the sky, and has the right time scale for what Chandra needs to do to be able to function. You know, what is there that we just hammer on, irrespective of our particular, you know, our own particular areas of interest. What's the best that Chandra could do given all those constraints? Almost like an optimization for the science budget. Yeah.
I mean, one program I still hold great admiration for was the X-ray Titan, Saturn's moon. I don't know whether you know that program, but they picked a time when Titan was crossing the Crab Nebula, and then the bright X-ray mission from the Crab was passing through the atmosphere of Titan. I thought, wow. But you need somebody who actually knows of these events, and I don't know whether it's us. The amateur astronomers, you know, they know, oh yeah, on the 22nd of August, 27, you know, that's when I need to be. And then we look at this one, and we know that we don't. I don't know whether Chandra should maybe kind of create more awareness of really unique opportunities. When something is passing in front of something else, can be something passing by the Crab Nebula, but it's just an example. But who would think of these things, and how do we find these people who are aware of these long-term calendars that during the lifetime of Chandra can alert us of the opportunity? And these may not be people who are familiar with the AO policies and so on, and to kind of reach out to them. Or look ourselves, you know, it's probably somewhere. Many of us don't even know when the next solar eclipse is going to be on. So just joking, exaggerated solar eclipse, you know, but these tiny things, you know, when something is eclipsed by the moon, for example.
So you're talking about a grading observation?
That was a grading observation.
What? No.
Yeah.
I guess with about 20 minutes left or something, you know, maybe we should think about our deliverable from our group. There was a little bit of a recap. I mean, there was support for the idea of like maybe Chandra could increase its allocation of time for TOOs, right? Yeah. That seemed reasonably popular, I thought.
What about even just having an allocation for grading spectroscopy? Because it seems to be harder and harder to get. Yeah. And the director's office says, no, there's no bias. We are allocating time in according to proposal pressure. But I think proposal pressure is going down because people don't put in the effort. It takes time to write these proposals. And if you're asked, and you realize you're asked 200, 300 kiloseconds, you might not put in the effort.
And before you know it, you're in the large program category.
Yeah, that's
more competition.
And that's where the bed breaking rules thing came. What will Chandra operations be willing to do?
Right.
So if they want to accomplish something
like in this last AO, there were only 4 HETG proposals approved. I don't know how many were requested.
Oh, lucky me.
And I was going to say, and some of the four that weren't TOOs. Yours were TOOs. Yeah. And then there were like about a dozen TOOs. And what success rate do you have on your TOOs? You know, are they guaranteed to trigger?
Well,
okay, so we can add a few more because I don't know how many of the TOOs are guaranteed to.
No, they're not guaranteed.
But it was a pretty slim show.
The HETG, it's only less.
Yeah, no, it's yeah. So
I agree completely there, Dave. I mean, I think that there is a negative feedback between grading observations being approved and being proposed, and being approved and being proposed. So it just keeps going down and down. So if there is a
really kind of, you wonder why it's that way when all the next generation missions are high resolution. You know.
Yeah,
you want us to DoorDash you some coffee?
Yeah.
No, I also fully agree with what Dave and Vinay have said, and I think if we write it on paper and say that this is a community wish, maybe it will be looked at. And it's absolutely the same problem with XMM. Because it's the same problem. The grading observations take more time, and therefore they're getting not competitive.
But it'll take time to convince the projects.
Yeah, so we have to have a justification, a convincing argument for why to carve that out.
Well, but we all know that committees work peculiar ways, you know. They will not give all time to just one project. No. And large category programs, you know, you compete. Yeah, I think.
It depends on the KPIs, right? Key performance indicator, which is number of papers per kilosecond of invested time. And then, of course, if you have one 500 kilosecond grading observation, you get one paper. If you if you have one 10 kilosecond observation of some pulsar, you have one paper. And then, of course, they go for the. I mean, this is how at higher levels, when I don't know exactly with NASA, but when ESA missions want to request extension, then the key performance indicator is publication rate.
Well, no, there's also
oversubscription.
Well, there's also archival research that uses Chandra data more than once. Yes. But I think it means getting out the statistics, proposal submission,
but I don't think it
and acceptance statistics too. So it means working with the project to get at the data and knowing how to analyze it too. I mean, I think we could do that if somebody were really interested.
Well, I fully agree with you, but I tried this 10 years ago with Harvey, and this is the arguments that he threw into my face, even though I was a research fellow and it was stretched a bit more privilege. But you know, there was because the point is, if you want to get a decent RGS or LETGS spectrum, you need like 250 kiloseconds. And then you're not competitive in a regular panel. So you go to 300 kiloseconds, so you're in the large program, but then you have to pass two panels and all these things.
So yeah, it's double jeopardy. Yeah. But we have had the Chandra Deep Field Cell. There was a SAJ Star 5 microsecond. So these things do happen.
Sure, they do happen, but who would, I mean, if you have Eric Feigelson, okay, you know, then you somebody with a profile. But, you know, if you want a regular person, well, as you said, it's a huge investment of time. And if the chances to win that are so.
But if we're talking about legacy high resolution spectroscopy, it seems like there ought to be more use of Chandra's high resolution spectrometers.
Right,
to prepare.
Absolutely.
So what is to be done with the outcomes of these legacy discussions? What are you planning to do with it?
That depends on what our outcome is, right? Okay. If the outcome is that, say, this group puts together a couple of slides, then we're going to forward that to the project and say, look, we had a meeting of Chandra users, right? Here, users group, take that, here, see what we can do. I personally believe to a certain degree, it's like the German term is dicke Bretter bohren. Like you just need to do it again and again and again until eventually it sticks. So I don't want to write like a highly detailed, polished paper because I think that's a waste of our time. But if at least we can, we can get a one-slide summary, then to get that on the agenda, then I think that would be, for those things, that would be helpful.
We are a subgroup, and so it might be nice to collect the ideas, and there are more in the community that might be able to have input. Yeah, it's always hard to
or just sign on, right?
Yeah, sign on. That almost sounds like a white paper. I'm not sure, but
it's also like, what haven't we been able to do? I guess you almost have to prove that you're hurting in some way.
Currently, we have 16 points. We can read them out loud.
No, we proprietarize them.
You want to read them?
Well, what I didn't hear was like a whole lot of survey type of things. I mean, because it is costly in time, but it wasn't like, except for filling in the gap, it wasn't exactly a survey. That was more strategic.
Yes.
But it wasn't like, let's go.
Well, Chandra is a small field of view. It's not so suitable for surveys. Right?
Yeah.
You mean sky surveys, right?
Like Orion, right? Orion is, very detailed. So it wasn't like we need another sort of Orion type of thing. That really wasn't. That didn't seem to be a theme for anybody. It was more like greater allocation for TOOs, some particular
But there's a
objects.
lot of things
Well,
with wasn't the Spitzer joint programs, quite a lot of the Spitzer joint program were like field star forming regions, things like that.
Okay. Yeah, there was some things in the Magellanic Clouds, right? Instead of, or somebody was saying star clusters somewhere else, extragalactic, if we can do them. I don't know if they're any good enough.
Yeah, but at the scale that we're talking about,
Yeah,
I didn't quite seem, it was like wait and see as a TOO, and then
Yeah,
there's some. Can we fill in another Wolf Ray star? Can we fill in another? We sort of say we had all the other ones filled in that one, whatever category, the doors and stuff.
Yeah.
Oh, good. Our tiebreakers here. Yeah.
Vote for B.
Door number 3.
So I'll say I can read them
Yeah, go
points
for
and
it.
then we select 5 if you think. Okay. What we want to see. Organizing information. I don't know why I wrote that. Specifically for transients. Extragalactic transients or objects. HRC stellar population, which can be done variability, or use it to get O spectra for stars. What are the objects that have not been observed? What are currently the most important targets to be observed? Filling programs with XMM and CAT targets by Moritz. Test star brights in ROSA. You wrote that. Wolf-rayet stars, spectra using the HRC camera for WO, WC stars, or magnetic stars. What about runaway stars? And then what can Chandra do for future low spatial resolution missions, preparing or supporting other missions? Wolf-rayet in binaries with Chandra, monitoring campaigns. For example, there's existing observations of Wolf-rayet 140, Etagar, Cygnus X1. TOO for new stars when X-ray bright, like Nobi, for example. These are difficult to schedule. Lens clusters, like Lida said. Monitoring low mass X-ray. Yeah, is that Ellen? Binary stars to catch planets through eclipses. Planetary material being accreted by white dwarfs. Catalogs are not exploited. 15 is think of only allocations for grading. Need long exposure. This is a proposal for changing the panel guidelines. And then the last one, the liaison with amateurs.
Well, I think many of these points are things any of us could propose, like picking up the exoplanets around white dwarfs. That's just regular community proposal. I think if we want to burn down this list to reduce it a little bit, we perhaps focus on those that might be of interest for policymakers, right? Like what Dave said about kind of making it worth the effort to write grading proposals to push them in some way. Or the last one with the special events where maybe you really need to have proposals who would write that. So a lot of the proposals seem to be something that, like the lensing. I mean, that's a fantastic idea, but I would then reply back, Lida, why don't you just write a proposal?
Exactly, yeah. So can you cut it off? I mean, I really didn't think about it. Maybe it's fantastic, maybe it's stupid. So not to disseminate again.
We need to honor your intellectual property of that.
Well, I think what you're saying is that the community buy-in, I mean, like, there's 30 megaseconds in a year. How much on-target time does Chandra have? Not megaseconds, not taking data all that time. What's it duty cycle, 50%? Or 70%? What's the question?
How many megaseconds per year, per AO, can Chandra allocate?
About 15.
15, oh, okay, so 50%.
And then 2 are going to start.
Sometimes less. Past cycle is 1.2 megaseconds. It's based on the demand.
Partially, that means we just need to write really crap proposals for stars because it drives up the demand. Like if everybody puts in a puts in 399 kilosecond proposals.
Yeah.
And that starts will get a lot of time.
Yeah, but that's okay.
I can write that.
But we didn't come up with any like, oh, we need to observe blah, 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 and get a ground-based campaign and get some theory behind it. So we don't have any like coherent single program, I guess is true. I mean, we didn't come up with something that Chandra needs to do.
Yeah. Well, because proposals do that. I mean, if any of us has a
but
idea,
that could have been something we decided to do, is write a proposal for to put something into the archive along with the theoretical support, ground-based support.
How does Chandra actually could support coordinated campaigns? I mean, they're joint programs. Fine,
yeah, there are.
But
each observatory allocates some amount of time.
But I mean, if like you say, if somebody comes, I want to follow this with my own garden observatory. Okay, we don't have a joint program with that, but I would like Chandra to adapt to when I can observe with my garden observatory.
Check coordinate.
Okay.
Ground-based.
So it does not need to be a telescope off the joint program.
It would, yeah, but
it would be time constrained, and then you're on budgeted again. Yeah. Okay.
But they're also like checkboxes for new stars with.
Sure, when it's in the joint program, yeah, but I think XMM is generous there. If you say I want to coordinate with something that's not in the joint program, they also support that. Maybe it's best effort you have.
You can say I have.
Okay, so it's there. That's good. Yeah.
We are running out of time. Does anybody have some final comments or recommendations? That's remote. By the remote group.
People, I don't know. People who are in the, I don't know if there is something like that, but people who are thinking about the legacy that China can provide for future missions like Prism, then getting people who work on stars and are in the Prism science team or whatever, and just communicating, I guess that's one way. I don't know how to do that, but there's a white paper. I just one that I've seen on this community on the Norfolk side, so maybe having a home yeah, right. So yeah, so things like that, and then building a communication.
There are special situations that happen, like these examples that you came up with, but like Epsilon Orija had is a 33-year period. And very eccentric, and had this campaign a few years ago. Is there anything on the horizon for stars that is just kind of like magical? This is not going to happen again for 100 years or something like that.
Not for 100 years, but for
it really deserves X-ray, high resolution X-ray spectroscopy. I'm sorry, what?
You just received an email about something that happens at the I forgot the period. It's a symbiotic star in the SMC, and it's getting close to Periastron, and it's having big activity, so it will be good time to observe it.
Yeah, there can be certain things like that that can really be, groundbreaking, transformative. We didn't have Chandra when this happened last time, or we really didn't get the attention it needed. We took a look, and there was a teaser there, but we really need to hammer on it if we want to get better science, better insight on it. Important.
There's of course, I mean, we lose a lot of opportunities. I mean, T-Pix, I forgot the name now. The Nova we're expecting in April, right? T-Pix? T-Series, yes. T-Corona. So, I mean, one could argue, we knew this is a Nova that appeared 1945 last time. That's now we know from the optical development that it's going to be exploding next year, probably in about 12 months.
We don't know anything for sure.
Well, we don't know for sure, but it's if it explodes, we have time. You don't need to require fossil, but then Chandra should observe it if it's visible at least. For XMM, it's probably not going to be visible because XMM has the
like a TOO, not a.
Yeah, but that would be DDT because I mean you have the time. Okay, good. Yeah. But it happened.
It can be observed again, so maybe we want to.
It's not like WR140 has like an 8-year period or something. That already has a program where they monitor.
I read recently something about 30 years. I can remember what it was. These papers seem to having observed after like 30 years of event. So these things would be nice to single out. Of course, people then write them into the regular program. Sure. But the regular AO, they may not prioritize this so high because they have other criteria. They don't look so much for unique opportunities. They just look for their budget. So the policymakers in general are interested in making use of unique opportunities, may set aside some time for unique opportunities that happen now. Next time in 30 years, Chandra will be dead then. While a regular panel may also see that and find this interesting. But then they think, well, you know, I'd rather spend 100 milliseconds on this other thing, even though it's less unique.
I mean, I think we're talking about then break the rules where somebody up high says, look, you know, a group of people come together and got community buy-in and they really want to, so we're gonna carve out this time. We're gonna do this thing. Yeah. And it's not part of the regular program.
Exactly, that they don't pay for.
Jesus, do you have enough notes to make the 4 slides he's requested?
Yes.
It doesn't have to be slides, whatever.
I'll just
note something. Yeah. Just scribbled. Yeah.
Okay. Yeah.
What responsibility.
And we should all become friends with Marina.
We are already.
Yeah. Yeah, we'll have a good share. I mean, Marina does the Chandra observation, I do the XMM observation. It works really well. And then we will share the data. So for the organizers, are you happy with? Okay, so this has been good. Yeah, it's been good. Right? Are you happy with us? Yes. Have you performed according to your expectations?
I'll ask you, did you think this format was useful? Should we recommend that for the next Chandra conference to do it again?
I enjoyed it a lot. It's really good, yeah. I mean, we were lucky because we had a good chair. And so I had a good minute taker. I mean, which group can find so quickly without?
Well, we'll find out tomorrow if the other groups are doing as well.
Yeah.
I guess just in closing out, Lita, thanks for joining from a difficult time zone, and everyone else who's joining remotely.
Yeah, Lita's already half asleep.
Appreciate everybody's comments and stuff like that. So 6 o'clock. Okay, I got to return the owl now. Yeah. Collect the owl.
Thank you all.
Thank you. Thanks, everyone.
See you tomorrow.
See you tomorrow.
First talk on time.